Now that we have the basics of vectors down, we should start asking things like, what can we do with vectors? Can we add vectors, for example? And the answer is yes, we can add vectors. And let's see how we would do that. So u plus v, or v plus u, I should say. V plus u is simply going to be, we're going to take the two vectors and add them. So I'm running out every step here. And how do we do this? Well, we just add their corresponding components together. So the first component of v plus u is just going to be the first component of v, which is 3, plus the first component of u. And you can see, just visually, you can see what's happening here. The second component of v plus u is just the second component of v plus the second component of u, which in our case just becomes 4, 6. So when we add vectors together, we get a new vector. And here we got the vector 4, 6. Okay, so just to save some space, let me erase these steps here. I'll move this over. Okay, so let's now look at this on a graph. Here is u and v, u in yellow, v in blue. Real quick, because I haven't mentioned this yet, vectors have two things. One is called a tail, its starting point, and the other is called a head, its ending point. I mean, they have more than two things, I guess, but they have a head and a tail. So when we add vectors, we line up their tails at a common point. Here we pick the origin just because it's convenient. So we line up their tails at that common point. And then to add them, we just take, we're going along v, and then we take u and place its tail to the head of v. So you can see what this corresponds to. This is like going along u plus v. Or sorry, going along v plus u. And now the new vector is just the vector that starts at their common starting point and ends at that addition. Oops, sorry about that. So that new vector is the vector v plus u. And we know it has components 4, 6, which makes sense if we think about it. V took us over 3 in the x direction, and u took us over 1 more, so that would be 4. So the new vector, v plus u, went over 4 in x, and we could do this a similar thing to show that it went up 6 in y. Okay, what else? Well, notice that we could have, if we wanted to, have gone along u first, and then added v, and we would have got to the same point, which means we would have gotten the same vector. So u plus v is the same vector as v plus u, which tells us that vector addition must be commutative. Vector addition must be commutative. And we'll prove that in a few videos from now. We'll prove that vector addition is commutative, but just visually, this is kind of a geometric proof that it must be.